Hey guys, so I have a bit of a problem. I'm a new student at my new school and I don't know where to go. So I'm going to use GPS and I'm going to teach everybody about GPS. So just like this scenario takes us back to the past, we're going to go back to the past and we're going to explore the history about the global positioning system. So the GPS originated in the Sputnik era. The Sputnik era was when the Russians launched rockets with satellites in them, and basically the rockets just separating the satellites inside, and the satellite stays up in the air in space. So then they launched them up into space, and then what happened was the Doppler effect was created, which was where they tracked the radio signals from the satellites, and then they could find locations and navigate. So the United States Navy in the 1960s did experiments with their U.S. submarines. They had nuclear weapons on the submarines, and then basically they used around 6 satellites to track where the submarine was to pinpoint its exact location in a matter of minutes. So in the 1970s, the Department of Defense wanted to ensure that there would be a stable satellite system available. So they took the Navy scientists' ideas with their experiments from the 60s, and they eventually came out with a navigation system that had timing and ranging, which was in 1978. And then finally, the GPS we all use today, it runs off of 24 satellites, which finally became operational in 1993. The Global Positioning System is a utility owned by the United States Air Force, which provides users with positioning, navigation, and timing services. It operates on 3 segments. The first segment is the space segment. The space segment is the satellites, how the satellite sends radio waves to Earth, to the computers that they have and everything that calculates all the important measurements needed so that we can navigate and travel really easily. The second segment is the control segment, which is exactly what I was just talking about, so there's the system where they monitor the radio waves and everything, and they do the calculations through these computers, and they're super quick and everything. So they basically there's people that work and they control these computers to make sure that the satellites are proper. And basically a major job of that segment is to adjust the satellite clocks. Gravity affects time, and since Earth has a stronger gravitational field than space, the clocks on Earth run slower. Space satellite clocks need to be updated to run 38 millionths of a second slower to remain in sync with the clocks on Earth. So that's mainly why there's people who monitor the computers, is because they always have to change the atomic clocks on the satellites, because the satellites orbit around Earth as well with us. So yeah, that's basically how that works. And then the third segment is us, the users. The equipment we use receives satellite signals and uses math and the transmitted information to calculate the user's position and time in the 3 dimensions. So it can tell us where we are, it can tell us where we want to go, it can tell us how to get there. All of that information is done by the monitors from the second segment. In the first segment, the satellite actually has to send information to the models and everything, but then all that information also goes to you, the user, with whatever device you want to use. Okay, so now I'm going to draw a little example to make the satellites and position make more sense. So first I'm drawing one satellite. We're going to call it satellite A. And we could be anywhere in this circle or along this circle, anywhere. And then I'm going to draw that satellite again. And then I'm going to add another one to it. Now, satellite 2 is going to be satellite B. And then, so at this point where they intersect and at this point where they intersect, we could be at any one of those 2 points. So then I'm going to draw the same picture again. And then I'm going to add a third satellite. I messed that one up. Alright, so I messed it up a little bit, so I'm going to draw a C, and then we're going to pretend that right here they're actually all intersecting. And then with the 3 satellites, this would be the only place that you're allowed to be, that you're actually positioned at on the GPS. So Usually the GPS uses a minimum of 3 satellites to find your position, and that way it can tell you, say if you're in your dorm right now and you want to go to over here, which is your classroom. So basically it can tell you how to navigate from your position. This is how it finds your position, which is the 3 satellites. And it could tell you, oh, do this, right? And then that's basically how that works. And usually GPSs use at least 4 satellites just to get better results. And yeah, so that's an image of how that works. So earlier I discussed the control center, the control segment, where there's control stations and they control the clocks on the satellites. And basically they need to do this because of special relativity, which is the relationship between space and time, and because of general relativity, which are the laws of gravity. So Earth's gravity forces our clocks to be slower than the gravitational pull in space because it's farther up, so there's less gravitational pull in space. So the clocks run faster by millions of seconds, so the control stations have to turn these clocks backwards so that they match our time on Earth, so that our GPS runs properly. And basically, I'm not going to go too far into this because the next presentation should be about this, but this is a segment that you have to at least have some knowledge on to understand how the GPS works. So the GPS is very impactful technology. So today I'm assuming a lot of us use the GPS for many reasons. Not many reasons. We use it to go from one place to another. So for example, when we're traveling home for Thanksgiving break, if you're driving, you're going to use the GPS. Or say if you're going on summer vacation and you live in New York and you're going to California, you're going to use the GPS. So it's impactful because we might even use it every day, whereas we'll just look up a pizza place and we'll go there from our own homes. So something to think about here is the accuracy of GPS positioning. It's accurate enough to give us directions for basic traveling, even flights, so it's pretty accurate. But the idea of it being accurate enough for self-driving cars is currently something that is a flaw. It's not ideal because I don't know if you've ever been driving or if you've been in the car with somebody and then they accidentally miss a turn. That just shows you that GPS systems are not as accurate yet to suit self-driving cars. And then on top of that, the pros of the GPS system is that you can really almost have a GPS system anytime, anywhere at this point. You can get them on your phone. Some of them are already built into cars, in your radio system, in your computer. And you can even just buy a GPS system by itself. The cons of having them on your phone is you're most likely going to use your data. And another couple of cons are they're not really suitable for self-driving cars yet. We can improve them. We can improve the accuracy. So another somewhat con would be that a GPS, depending on who the person is and how they drive and whether they pay more attention to the road or not, can be really distracting and might even cause accidents. That's not likely though, but it's possible. It's never not impossible. And then, so basically to wrap this up, we really have to think about how we can make the satellites, whether we have to change the computerizations or the mathematical equations or whatever we have to do to make the system more accurate so that we can use it even further, like in self-driving cars. And so that just a short step to improve this would figure out how to make sure that our car doesn't lag on the system. Like, I don't know if you guys have ever looked at your GPS. Occasionally when you're driving, your car will go from like this line right here, and it'll go from here, and it'll just jump and then jump because it's not pinpoint accurate when you're traveling. So maybe we could improve that. And basically, we just have to figure out how to improve the GPS system. Although it's a pretty good system, it's helping us a lot right now, but there's always room for improvement. Hopefully you all understand and learn something about the global positioning system, and now that I know how, I am going to head to class.